Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at circle theorems. We're going to be focusing our attention on tangents to a circle. To get us started, we're going to be taking a look at the definition of a tangent line. So what are tangents to circles, to be specific? Let's go ahead and take a look at the definition. A tangent line to a circle is a line that intersects the circumference of the circle, that intersects the circumference of a circle at exactly one point. Okay, so we can see it illustrated to the left. This line right here, that line is a tangent line. Okay, this is a tangent line. Why is it a tangent line? Because it intersects this circle right here at exactly one point. Okay, that point where the tangent line, so this is a tangent line, that point where the tangent line intersects the circumference of a circle at exactly one point, that point is called the point of tangency. Okay. All right, so there you have it. Now there's a special relationship between a tangent line and the radius or diameter of a circle that has an endpoint on the point of tangency. All right, so let's go ahead and write that down. And the relationship is as follows. A tangent line to a circle forms a 90-degree angle. So it's perpendicular with what? Forms a 90-degree angle to the radius, or by extension, diameter of the circle that has an endpoint at the point of tangency. All right, we're just going to refer to this as POT in this problem, okay? At the point of tangency. So here in this particular case, we have a radius, okay? We can extend it to make it a diameter, but the radius, one of the endpoints of the radius is on the point of tangency. So what does that tell us? It tells us that this tangent line is perpendicular to the radius. This is a 90-degree angular separation right there, okay? So this is a very, very important theorem that we can keep in mind for the tangent lines to circles and use it to solve problems. So let's go ahead and take a look at some formulas. All right, so we're looking at three cases here. We're going to be generating three sets of formulas. So the assumption is that the lines that look like the segments that look like tangents to the circle are actually tangents. Okay, so let's assume that the segments that look tangent to the circle are tangent segments. Okay? All right, so let's take a look at the first one. So in the first one, the relationship is as follows. So first of all, this line is a tangent line right here. So this is a tangent. And this is the radius. Okay, so we know that this is going to be a 90-degree angle. So what is going to be the relationship between x, this angle right here, and y? We know the triangle angle sum theorem, right? The sum of angles in a triangle is 180 degrees. So we can set up the formula x plus y plus 90 is equal to 180 degrees. That's one equation you can write. Or it could be simplified to the following. Since this angle is 90 degrees, the remaining value of angles available to these two is 90 degrees. So it follows that these two angles are complementary, or they add up to 90 degrees. So x plus y is equal to 90 degrees. So any of these two equations will suffice, okay? All right, so let's take a look at the second case. So we have two tangent lines. So let's say this line right here is this segment is a tangent segment, and this is also a tangent. And then this is a radius right here, radius. And then this is another radius. All right, I forgot to say it. So this point right here is the point of tangency. And then over here we have 2 points of tangency. So this is a point of tangency right here. This is another point of tangency. So the point of tangency, the angle between the radius and the tangent line at the point of tangency is always 90 degrees. So this is 90 also, and this is 90 degrees also. Okay, so so let's mark these two angles over here, x and y. So what's the relationship between these two angles? Well, we have a quadrilateral here, and we know what the sum of the angles in a quadrilateral is. It's basically composed of the sum of two triangles, which is 360 degrees. So in this particular setup, angle x plus y plus 90 plus 90, sum of angles in a quadrilateral is 360 degrees. Or if you simplify it, just remember that if you have a quadrilateral formed by two radii and two tangent lines, like this, with this kind of configuration, opposite angles are supplementary. Okay, so here x plus y, guess what, is equal to 180 degrees. If we think about it, it makes perfect sense because these two add up to 180 and everything adds up to 360. Okay, so these two have taken up the first 180 degrees, so you just left with 180 to share amongst the other two. All right, so let's take a look at the last case. So let's say this is a tangent segment right here. That's a tangent segment. And this line right here is your radius. And this is your point of tangency. All right, so what is the angle there? This angle right here is 90 degrees, okay? So let's say we have side lengths A. See, this is A right here. This is A, and this is B, and this is C. What's the relationship between these three sides? Well, since this is a right triangle, we can form a relationship between the three sides, which is that A squared plus B squared equals C squared. What is this known as? This is known as your Pythagorean theorem. Okay? All right. So now we are going to use these formulas to guide our problem solving process. All right. So the instructions for the examples are for us to find the value of x, and we're going to make the assumption that the segments that appear tangent to the circles are actually tangent. Okay? All right, so let's take a look at question number 1. So for the first one, let's identify our tangent line. So this line right here, this is the tangent line. All right, this is the radius, as you can clearly see. Radius right here. And this is our point of tangency. So what do we know? We know that the point of tangency right here between the angle formed at the point of tangency between the tangent line and the radius is 90 degrees. So what kind of equation can we set up here? We know that these two angles are complementary. They add up to 90 degrees. So we can say either x plus 30 is equal to 90 degrees, or we can just say, if you want to write a whole thing, you can say x plus 30 plus 90 is equal to 180. Okay? Now look at this. If we subtract 90 from both sides, we'll have x plus 30 is equal to 90 degrees, like we indicated earlier. So that's another way of doing it. So let's just do it this way. So we add these two angles, 30 and 90. We get 120 degrees equals 180. So this equation up top here is the triangle angle sum theorem. Okay? And then we're going to subtract 120 from both sides of the equation, and then that will give us the value of x. Okay, and then x is going to be 60 degrees. We can clearly see that this angle being 60 makes it a complement of this other angle, which is 30, which is what we indicated earlier. All right, let's take a look at question number 2. So for question 2, you notice we have two tangent lines. So this is a tangent line right here. This is a tangent, and this is another tangent. And then we have two radii. So this one right here is a radius, and this is a radius. And then that results in 2 points of tangency. Okay, so that's a point of tangency right here, and this point here is also a point of tangency. So we know that the angle formed is going to be 90 degrees and 90 degrees. All right. So if we add all these angles together in this quadrilateral, is going to be 360 degrees, right? But since these two add up to 180, we automatically know that the other two are going to add up to the other 180, because opposite angles, when you have a quadrilateral formed by the radii and the two tangent lines, opposite angles are supplementary. Okay, so with this kind of setup, just recall that opposite angles are supplementary with a setup like this. So we have the situation where x plus 35 is equal to 180 degrees. And then to get x by itself, simply subtract 35 from both sides of the equation. Okay, and then we're going to have x is equal to 145 degrees. Bam, bam. All right, let's take a look at question number 3. Now we're working with the sides. Okay, previous problems we're working with the angle. So let's label the sides here. So this is a tangent line right here. This is a tangent. And then this is a radius right here. Okay, they meet at a point of tangency. That point of tangency is going to be 90 degrees. So what type of triangle has 90 degrees? Any triangle that has 90 degrees is a right triangle. Okay, so since it's a right triangle, we can use the Pythagorean theorem. All right, so since the triangle is a right triangle, the Pythagorean theorem can be applied. Okay, so what is the Pythagorean theorem? Well, the sum of the squares of the legs is equal to the square of the hypotenuse, right? So the shorter sides are the legs. So let's say this is A, one leg is A, the other leg is B, and the hypotenuse C, the longest side or the side opposite the 90 degrees is your hypotenuse. That's what we're looking for, okay? So A square plus B square equals C square. A square, we have 2 square plus 4 square equals C square. We know what C is. C is x, so we might as well just put it in. So equals x square. Then we simplify that. 2 squared is 4 plus 16 is equal to x squared. 4 plus 16 is 20. 20 is equal to x squared. So to solve this resulting quadratic equation, we're just going to take the square root of both sides. Okay, so with square root and square root, we're going to have x is equal to the square root of 20. So let's see if we can simplify that. Square root of 20, let's do it on the side here. So 2 goes into 20 10 times. 2 goes into 10 5 times. So this 2 and this 2, that's a perfect square, right? That's 2 square. And then when you take the square root of 2 square, you get 2. So this comes out as 2. And then this one is it's not a square, so it stays behind. So the square root of 20 simplifies into the 2. That comes out as the square root of 2 square. And you're left with root 5. Okay. So the final answer for this problem, x is equal to 2 root 5. That's the value of x, or the hypotenuse of this right triangle right here. All right, so let's take a look at 2 more examples, extension problems involving the problems we just worked on. So let's take a look at number 4. Let's say this is 52 degrees right here. And this angle is x that we need to find. Okay, so you can see the tangent lines and the radii. So this is a tangent right here. This is also a tangent. And this is a radius right here. And this one also is a radius. Okay. So if you have a setup like this, first of all, since we have 2 radii, we know that radius is constant for a circle. So this side is congruent to this side. So this angle here is also x. Okay, this is x degrees. And we talked about it earlier, and then let's call this one y. We said for a configuration like this, opposite angles are supplementary. Okay, so remember we said opposite angles are supplementary when you have a quadrilateral formed by 2 radii and 2 tangents. So opposite angles are supplementary, basically telling us that angle y and 52 are supplementary. That's for, we're looking at the quadrilateral, okay, not the triangle. So looking at just focusing on this quadrilateral right here. So these ones are supplementary, and then these ones are supplementary also. Okay, so with that setup, we know that y plus 52 is going to be 180. Okay, so we subtract 52 from both sides. Bam, bam. We subtract 52 from both sides. We're going to get a value of y. Y is going to be 128 degrees. Okay, so if this is 128 degrees, we have a triangle. So the sum of the angles in the triangle is 180, right? So we can use the triangle angle stem theorem to write the equation y plus x is equal to 180. Sum of angles in the triangle. Okay, so 180 is y is 128 plus 2x by substitution. Okay, equals 180. So we can subtract 128 from both sides of the equation. Subtract 128 from both sides. And then we're going to have 2x is equal to, so 10, 2, 7 minus 2, 5, 52. And then to finish this off, just simply divide both sides by 2. Divide by 2, divide by 2. And get the value of x, which is 26 degrees. All right, now let's take a look at the last one, problem number 5. So for question 5, let's say we have the following setup. Let's say that this angle right here is unknown. So this angle right here is our x. Okay, and this angle over here is 32 degrees. So we want to find x. Alright, so with this setup, this line right here is a tangent. There's a tangent line. And this is your radius right here to the left. And then there goes your point of tangency. Alright, so to do this, just name some angles. So let's call this angle right here, let's call this y. Now let's call this z, angle z. And then let's call this one right here, this portion is angle y. Alright, so based on the circle theorem we just talked about concerning tangent lines and radii at point of tangency, we know that this entire angle is going to be 90 degrees. Okay, so that one is going to be 90 degrees right there. Okay, all right, so to get us started, we can find out what the measure of angle z. We'll find out what the measure of angle z is. Let's make a quick correction right here. We can use a different approach. How about we call, so that one is 90 degrees, okay? How about we call this, since this is a radius right here and this is another radius right here, this portion right here is also a radius. So we have an isosceles triangle, okay? So this angle right here, we can call this y and call this y also. All right, so this is x, y, y, and z. So we're going to find z first and then use the idea that's an isosceles to find y. And y is a supplement to x, so we'll just find out what x is. All right, so let's first of all find z first. So to find z, we know that that's 90, 32, z. These two are 32 and z are complement, okay? Or we can just say z plus 32 plus 90 is equal to 180. Same thing. All right, so z is going to be, add these two together, 122 equals 180. So now we're going to subtract 122 from both sides in order to get z isolated. So subtract 122, subtract 122. When we do that, we're going to get z is equal to 10 minus 2, 8, 7 to 5, 58 degrees. All right, so z is 58. We have that down, okay? So if z is 58, we know that when we add z and these two y's, we're going to get 180 with the triangle angle sum theorem. So we're now going to find y, okay? Now to find y, we know that z plus y is equal to 180, the sum of angles in a triangle, right? So z is 58 plus 2y is equal to 180. Okay, so we'll subtract 58 from both sides. Let's do that, subtract 58. And that will give us 2y is equal to, find a difference here, we're going to have 122. All right, and then to get y by itself, we'll just simply divide both sides by 2. So divide by 2, divide by 2, and then we have y is equal to 61 degrees. Okay, so now that we have y, we can now find the last piece, which is x. So to find x, we just know that y and x they are a linear pair, which means they're supplementary, right? So x plus y, you can see that right here, x plus y from a linear pair. X plus y is equal to 180 degrees. We know what y is. Y is 61 plus x is 180. And then we just simply subtract 61 from both sides. Okay, and that'll give us our final answer. X is equal to, so 10 minus 1, 9. And then 17 minus 6 is 11. 119 degrees. So that's a measure of angle x. Alright, so that's how you basically use the circle theorems involving radius and tangent lines and diameters and tangents to circles to solve problems. Thanks so much for taking the time to watch this presentation. We appreciate your support of this channel with your likes, subscriptions, and comments. Don't forget, we have tons of support resources at Mathgotserved.com to check it out. Thanks again for watching. We'll see you in the next video. Goodbye.